Okay, let's finally look at, there's no finally I know, look at what's really going on with reactions when we use this matrix calculation, because in all reality, though we are putting down ones and zeros and ones, we are really putting down some variable calculation of something that's reacting. So we've got a reaction here and here, and a reaction on a simple problem that we know the answer to. So let's put it something we know the answer to. I'm going to make this a distance 10, and right there in the middle I'm going to add in a force. So I'll make the force green of 10 at 45 degrees down. So down bubble 45 degrees. This is 10 pounds. Of course, this is a distance 5. This is a distance 5. How are we actually doing the mathematics of this? Well, we are starting with this, remember. We'll go ahead and realizing that's reaction in the A and the reaction in the Y, and the X and the Y at A, and this is at B. We solve for the reactions, and then we can cut the structure anywhere we want. So what are we actually doing when we're solving for the reactions? We are making sure that the sum of the moments of all the externals are, or all of the applied forces, are equal to the opposite of the sum of the moments of that force. So we go about doing that by, of course, grabbing the right color pen, let's say, to do some writing. See how that one works. And we're going to go ahead and write, we've decided two matrices here, both with asterisks, because we do not know the magnitude of them. And we say, well, these are both, the location is 0, 0, if we assume that's our origin. And we have 1 in the x, 0 in the y, and the other component has 0, 0, 0, 1. What did this mean? This meant basically lambda. That was lambda. Those two together add up to be lambda. So this is for this force. This is the unit force in one direction, unit force in the other direction. Those both get asterisks. These ones here, it's applied at 10 and 0. And this, of course, is 0 and 1, because there is none that's 0 and 0. Later on, if you have a statically indeterminate problem, you will have a 1 and a 0 here, because you might have two pin joints. And then, of course, this one, we remember, I don't know if we can do it by hand, but we know that this is at 5 and 0, and this is in a positive x. So the x here is 7.07, if you remember, and the y is minus 7.07. And so in all reality, what we're really doing is we are calculating the moment. We're doing the sum of the moments about point A, and it has to be equal to 0. And we know in all reality what we've done here is, this is actually not 40, it's 10. We know that 1, right, 1 unit of force in that direction leads to 10. Right, so that's got an asterisk. Right, we know that 1 unit of force leads to a moment of 10. We know that the applied forces here, and again, you could take it back to unit vectors, you know that these multiply together, and realistically, think about it. There's that trigonometry that comes in. This is around minus 35. Thereabouts, because I don't want a 35.35 equals minus. In other words, here, this is minus 35.35, about 0.00. That's about point A. And so that means that over here, your reaction is going to have to be 3.5 up. So in other words, it's not 1. It is 3.53 up. So it is reacting. And what is this value? Well, basically this value is the ratio of the sum of the moments of the external, right, divided by the moment of the unit force. So the reaction at B is actually the sum of the moments of the external forces divided by the moment of a unit force. And so that's how we got our 3.53. Once again, you can then switch your coordinate system here and do the same thing. The reaction at A is equal to the sum of the moments of the external, and that's A and the Y basically, divided by the moment of the unit Y force at A. And so when you put up together a spreadsheet, the reactions are no longer these hard and fast numbers. They are something that reacts to other forces, other values. And so you can do it individually or by sum. The concept of superposition means that you would actually have a whole set of reactions that you just add together. So the obvious case in this point would be if we all of a sudden put a force out here that was counteracting, maybe going up in this direction, we could counteract it far enough that the sum of the moments was 0 and this would feel no force, but you still would have some sort of forces here because of the fact that these are not concurrent. It's going to have to add a reaction back. So this is just a way to look at it. And I've seen a few students come very close to kind of doing it as they're laying out their spreadsheets. You're laying out something that's very reactive and it's geometric. And so once you do that, once again, you can go back later. And in this case, it becomes not so easy to say what's behind this is not important. There's a two-step process. First is to recalculate the reactions and then say what's behind this is not important. And so if you think about this way, this is 3.53 up. And of course, this was 3.53 up in this case. This is going to be a reaction in the Y of 3.53. And this, of course, would have to be minus 7.07. If we change the force, however, we would have to redo things. And then once we had recalculated the reactions, then what's behind this is not important as we shift our coordinate system around. So one of the concepts you need to do is to learn to solve for reactions. And I will take then a written paragraph that explains this process for you in other words, in lieu of, and in hope of actually getting to a point where you don't necessarily let the math overrun you when it comes to the simple determination of interior and internal forces, which of course lead to internal stresses. And I'll work on that paragraph in my words over the weekend and post it out. We had about 10 things really we're supposed to get out of that class. One of them is solving for reactions. And just so you know, solving for reactions internal and external is the same thing. All right, we'll see how this looks, how it's posted, and we'll take some comments on it. Thanks for listening.